All right, let's talk about one of the biggest questions in tech right now. How do we actually build AI systems that we can trust? It's not enough for AI to be powerful. It has to be responsible. So let's dive in.
Let me paint you a quick picture. Imagine you're applying for a loan, something you really need. A few days go by and you get a rejection notice. The only reason it gives? The model said so. That's it. No explanation, no one to talk to. How would that make you feel? You wouldn't just accept it, right? Of course not. And that exact feeling is why we have to talk about the architecture of AI.
Because what we're about to walk through, it isn't just a bunch of boxes and arrows on a technical diagram. Think of it as a control system, and its entire purpose is to build trust. See, AI doesn't just give us outputs. It makes decisions that affect real people's lives. So we have to have control over the whole process, what goes in, how it works, and how those decisions get used.
So to really wrap our heads around this, let's start with an analogy for what we'd call classic machine learning. Picture it like a super organized, professional food factory. Every single thing that comes out of that factory has to be safe, consistent, and totally trustworthy.
Inside this factory, every single stage is meticulously controlled. It all starts with the ingredients, which for us is the data. Then you have the model, which is like the cooking process itself, turning those raw ingredients into a finished meal. Then we serve that meal through an application. This all happens inside the infrastructure, which is our kitchen. And all along the way, you've got operations doing quality checks and governance acting as the factory management, making sure everything is up to code.
And here's the thing, everything, and I mean everything, starts with the ingredients. If your data is biased or incomplete or just flat out wrong, the decisions your AI makes will be unfair. Period. It really is garbage in, garbage out. The vast majority of AI risks start right here, at the data layer. That's why things like privacy, fairness, and data quality aren't just nice-to-haves, they're the foundation.
Okay, next up is the model, our cooking process. The model is just following a recipe, right? But what if that recipe is flawed? Or what if it's never been tested properly? Well, then the outcome is going to be unreliable, maybe even dangerous. You wouldn't serve a dish made from a recipe you've never tried, and it's the exact same idea for an AI model.
So now the food is cooked, and it's time to serve it. This is the application layer. This is the moment the AI's decision actually meets a person in the real world. This is where the impact happens. Can that person understand why they got that decision? Can they challenge it? Is there a human in the loop? Transparency and explainability aren't just buzzwords, they're essential for trust.
And this just nails the whole idea. Think about it. You don't trust a five-star restaurant just because it has one amazing chef. You trust it because you know there are rigorous controls at every single step, from sourcing the ingredients to how the plate is presented. Trust is built into the whole system.
And this leads us to the single most important takeaway for classic machine learning. All the control happens before deployment. All the checks, all the validation, all the safety tests, they're all done up front, before that system ever sees a real user. But the rules of the game are changing. With generative AI, we're not in that predictable factory anymore. Nope. Now, we have something totally different. Think of it like a brilliant, incredibly fast smart assistant. One that's kind of learning on the job and has access to, well, everything. And this right here shows the fundamental shift. Our ML factory followed a simple path. You train it, then you deploy it. It's a static, finished product. But the Gen AI assistant, it's completely dynamic. It is thinking, retrieving new information, and making decisions in real time while it's running. The architecture here is way more like a living thing. You've got the orchestration layer, which is like the brain, giving it instructions. It has a retrieval system, its library, which is where things like retrieval augmented generation, or RAG, come into play, letting it look up new info. The large language model itself is just the speaker, putting the words together. The tools and agents, those are its hands, allowing it to take action. And finally, operations is like a black box recorder, logging everything it does.
In this new world, control totally shifts. The real power, the real control, is in that orchestration layer, the brain. This is where we write the prompts, set the rules, and build the guardrails that tell the AI what it can and can't do. And just as critical is its library. If that retrieval system pulls from the wrong book or a bad source, the assistant will state a wrong answer with complete confidence.
The model itself, it's just a speaker. It's a world-class expert at predicting the next word in a sentence. But you have to remember this, its confidence has nothing to do with correctness. And here's where it gets really serious. When we connect it to tools, when we give it hands, it can actually do things. It can send emails, make payments, change data in a system. This is the point where risk becomes very, very real.
So here's the big counterpoint to our factory. With generative AI, control has to happen during runtime. It's not a one-and-done check before you ship it. It is a continuous process of supervision and guidance while the system is live.
And this is such a critical distinction to make. For these powerful new systems, the biggest risk isn't about what information it has. The real risk lies in what we give it permission to do with that information. Action is where the potential for harm lives. Okay, so we've got these two very different systems, right? The factory and the assistant. They work in completely different ways. But does that mean they're governed by different values? Absolutely not. And that brings us to the unifying principle behind it all.
Whether we're talking about the food factory or the smart assistant, the fundamental principles of trust are universal. Things like fairness, privacy, safety, transparency, accountability, and traceability. These aren't just features you can pick and choose. They have to be woven into the fabric of the architecture at every single layer for both types of systems. And that really brings us to the core thesis of this whole explainer. Trust in AI doesn't come from how amazing its capabilities are or how smart it seems. Trust comes from the controls we design and build around it.
So how do you know if a system you're building or using is truly trustworthy? Well, you have to be able to answer 3 questions when, not if, something goes wrong. Number 1, where did the problem actually start? Number 2, where in the system should it have been caught? And number 3, why did that control fail? If you can't clearly answer all 3 of those, you don't have a responsible system.
Let's end on this one final thought because it's so important. Responsible AI is not a feature. It's not a checkbox on a list you tick off before launch. It is an architectural discipline built into the very foundation of these systems from day one. That's the only way we get from just having AI to having AI we can genuinely trust.